In this problem, we're trying to find asymptotes of two hyperbolas, basically. This is a type of hyperbola. It's also known as quotient function, and this is another hyperbola that you saw in a section of its own, basically. So let's go back to the quotient function f of x equal to 5 over x minus 7 minus 6. A quotient function has a vertical asymptote when y goes to infinity as x approaches some value a. So it's of the form x equal to a, basically. It has a horizontal asymptote as x goes to plus or minus. This one also has plus or minus infinity. And then as y approaches, as x approaches x positive or minus infinity, y approaches to value b. In this case, we will have y equal to b to be the horizontal asymptote. Now let's go back to our own function. Here, as x approaches 7, the denominator gets smaller and smaller, so the entire function gets bigger and bigger, and either in a positive direction or a negative direction. So the absolute value of the function gets bigger and bigger. And so this is telling me that x equal to 7 is, x equal to 7 in here, as x approaches 7, is a vertical asymptote. So I'm going to put in x equal to 7. Now the next question is, when does this have a horizontal asymptote? So horizontal asymptote happens as x goes to either positive infinity or negative infinity. In that case, the denominator, the absolute value of the denominator, gets really, really large as x approaches either positive or negative infinity. Again, the absolute value approaches really, really large numbers. And so the 5 divided by really, really plus or minus a really, really large number is going to be 0. So this part becomes approaching to 0. Therefore, what's left is negative 6. And so the y equal to negative 6 is the horizontal asymptote. And I'm putting it here. Now, this type of graphs, this is not a graph of the graph of this shape. Curve is not a function. But this type of graphs do have asymptotes. They're slanted asymptotes. And so how do I find those? And so the best way is I typically take this term to the other side. So I write it as y squared divided by 25 is equal to x squared divided by 26 plus 1. Now, as x approaches positive or negative infinity, I can tell that 1 basically it becomes powerless compared to x squared over 36, because a very large x squared is going to make everything, all the numbers become powerless. So therefore, I can think about this, that the behavior as x goes to positive minus infinity is ignoring that, the 1, and it's going to be looking like this, basically. And now that I know the behavior looks like that as x approaches plus or minus infinity, then I can take the square root, say y over 5 is equal to x over 6. Wait a minute, what am I forgetting? plus and minus, and then solve for y. Basically, y is equal to plus minus, multiply both sides by 5. So 5x over 6. So one answer is 5 equal to 5, and y equal to 5/6 of x. The other one is y equal to negative 5/6 of x.